Look up at the night sky. It's a vast, mysterious expanse that has fascinated humanity for millennia. The twinkling stars, the constellations, and the occasional shooting star all contribute to the wonder we feel when we gaze upwards. On a clear night, far from city lights, you might see a faint smudge. This smudge, often overlooked, holds a significant place in our understanding of the universe. This smudge is not a cloud. It's not a trick of the light or an illusion created by our atmosphere. It's not even in our galaxy. This faint smudge is something far more extraordinary. It's the Andromeda Galaxy, our closest major galactic neighbor. Andromeda is a spiral galaxy, much like our own Milky Way, but it holds many secrets and wonders of its own. Andromeda has been known since ancient times. Early astronomers, with their rudimentary tools, were able to identify this distant object in the night sky. Persian astronomers called it the Little Cloud. This name reflects the limited understanding of the cosmos at the time, but also the curiosity and dedication of those early stargazers. For centuries, astronomers thought it was just a nebula, a cloud of gas and dust. This was a reasonable assumption given the technology and knowledge available at the time. But in the early 20th century, Edwin Hubble made a groundbreaking discovery. Using more advanced telescopes, he was able to observe Andromeda in greater detail. He found that Andromeda was not a nebula at all. This discovery was a turning point in our understanding of the universe. It was an entirely separate galaxy, millions of light-years away. This realization expanded our view of the cosmos dramatically. This was a revolutionary idea. It meant that the universe was far larger and more complex than anyone had previously imagined. It meant that our universe was far larger than anyone had imagined. The discovery of Andromeda as a separate galaxy was a monumental step in the field of astronomy. Andromeda, with its billions of stars, was another island universe, just like our own Milky Way. This concept of island universes opened up new avenues of exploration and understanding. This discovery changed our understanding of the cosmos forever. It challenged existing theories and inspired new ones, pushing the boundaries of human knowledge. Today, Andromeda is one of the most studied objects in the night sky. Modern telescopes and technology allow us to explore its structure, composition, and behavior in unprecedented detail. It offers us a glimpse into the life cycle of galaxies. By studying Andromeda, we can learn about the past, present, and future of our own Milky Way. It also helps us understand our own galaxy's future. The interaction between Andromeda and the Milky Way provides valuable insights into galactic dynamics, because in about 4 billion years, Andromeda and the Milky Way are going to collide. This cosmic event will reshape both galaxies, creating a new, merged galaxy in the process. Andromeda is a barred spiral galaxy, one of the most fascinating structures in the universe. Its spiral arms are a testament to the dynamic processes that shape galaxies. This is the same type of galaxy as our Milky Way, which means they share similar structures and characteristics, though Andromeda is much larger. It has a flat disk with spiral arms that wind out from a central bulge. These arms are filled with stars, gas, and dust, creating a beautiful and complex pattern. The bulge is home to older stars, while the arms contain younger, hotter stars. Andromeda is enormous, a true giant in the cosmic landscape. It's about 220,000 light-years across, making it the largest galaxy in our local group of galaxies. That's twice the size of our Milky Way, which spans about 100,000 light-years. It contains an estimated 1 trillion stars, a staggering number that dwarfs the star count in our own galaxy. That's more than twice the number of stars in our own galaxy, which has around 400 billion stars. Like all spiral galaxies, Andromeda is constantly rotating, a dance of stars and gas that has been ongoing for billions of years. The stars and gas in the disk orbit the central bulge, creating the spiral structure that we observe. The rotation period of Andromeda is about 250 million years, a timescale that is almost incomprehensible. That means it takes 250 million years for a star in Andromeda to make one complete orbit around the galaxy's center, a journey that spans eons. The universe is a dynamic place. Galaxies are not just sitting still, they are constantly moving and interacting with each other. Andromeda and the Milky Way are no exception. Right now, Andromeda is hurtling towards us at a speed of about 250,000 miles per hour. That may seem incredibly fast, but on cosmic scales, it's a relatively leisurely pace. It will still take about 4 billion years for the two galaxies to meet. The collision will be a spectacular event. The two galaxies will distort each other's shapes with their gravitational pull. Streams of stars and gas will be ripped out into space. New stars will be born in bursts of intense star formation. Despite the violence of the event, it's unlikely that our solar system will be destroyed. The vast distances between stars mean that direct collisions are extremely rare. However, the night sky will be forever changed. The Milky Way and Andromeda will eventually merge into a single giant elliptical galaxy. This new galaxy will be a cosmic tapestry woven from the stars of two galaxies. The merger of the Milky Way and Andromeda is not just a prediction, it's a certainty. Astronomers have been studying the motions of both galaxies for decades. They have used this data to create detailed simulations of the collision. These simulations show that a merger is inevitable. Section 5: Andromeda's Secrets. Andromeda is more than just a pretty sight in the night sky, it's a valuable laboratory for astronomers. By studying Andromeda, we can learn a great deal about galaxies in general. For example, Andromeda is helping us to understand the mysterious substance known as dark matter. Dark matter is invisible, it doesn't emit or absorb light, but it makes up about 85% of the matter in the universe. Astronomers can detect dark matter indirectly by its gravitational effects. Andromeda's rotation, for example, can't be explained by the visible matter alone. This suggests that the galaxy is embedded in a halo of dark matter. Section 6: A Window to the Universe. Andromeda is also helping us to understand the evolution of galaxies. This majestic galaxy, our closest spiral neighbor, offers a unique perspective on the life cycle of galaxies. By observing its structure and behavior, astronomers can draw parallels and contrasts with our own Milky Way. The Andromeda Galaxy, with its vast collection of stars, planets, and cosmic phenomena, serves as a cosmic laboratory, providing invaluable data that helps us piece together the grand puzzle of the universe. By studying Andromeda, we can see what our own galaxy might have looked like in the past. The similarities and differences between the two galaxies offer clues about their respective histories and evolutionary paths. For instance, the distribution of stars and the presence of certain types of celestial objects can tell us about the processes that shape these galaxies over billions of years. This comparative analysis is crucial for understanding not just where we come from, but also where we might be headed. We can also get a glimpse of what might happen to the Milky Way in the future. The impending collision between the Milky Way and Andromeda, predicted to occur in about 4.5 billion years, is a topic of great interest. This cosmic event will dramatically reshape both galaxies, leading to the formation of a new, larger galaxy. By simulating this future collision, scientists can predict the potential outcomes and understand the long-term dynamics of galactic interactions. For example, Andromeda has a much higher rate of star formation than the Milky Way. This heightened activity is a sign of a galaxy that is still very much in its prime, actively creating new stars and planetary systems. By examining these star-forming regions, astronomers can learn about the conditions that lead to star birth and the factors that influence the rate of star formation. This knowledge is essential for understanding the life cycle of stars and the evolution of galaxies. This suggests that Andromeda may have experienced a recent merger with another galaxy. Such mergers are common in the universe and play a significant role in the growth and evolution of galaxies. When galaxies collide, their stars, gas, and dust interact in complex ways, often triggering bursts of star formation and altering the galaxy's structures. By studying these mergers, we can gain insights into the processes that drive galactic evolution and the formation of new cosmic structures. The Milky Way is likely to undergo a similar burst of star formation when it collides with Andromeda. This event will not only reshape our galaxy, but also create new opportunities for star and planet formation. The resulting galaxy, often referred to as Milkomeda, will be a blend of the Milky Way and Andromeda, with new star systems emerging from the chaos of the collision. This process highlights the dynamic and ever-changing nature of the universe. Studying Andromeda also helps us understand the processes that drive the formation and evolution of galaxies in general. By observing its structure, composition, and behavior, we can develop models that explain how galaxies form, evolve, and interact with their environments. These models are essential for making sense of the vast and complex universe we live in, providing a framework for future discoveries and explorations. The interaction between Andromeda and the Milky Way is a reminder that the universe is not static. It is a dynamic, ever-changing place where galaxies grow, evolve, and sometimes collide. These interactions are a fundamental part of the cosmic dance that shapes the universe, influencing the formation of stars, planets, and other celestial objects. By studying these interactions, we can gain a deeper understanding of the forces that govern the cosmos. It is a dynamic place, full of change and wonder. The universe is a vast and mysterious expanse, constantly evolving and revealing new secrets. As we continue to explore and study the cosmos, we uncover more about our place in it and the incredible processes that shape the galaxies, stars, and planets that make up our universe. This journey of discovery is a testament to human curiosity and our enduring quest to understand the world around us. Section 7. Finding Andromeda. You don't need a powerful telescope to see Andromeda. It's visible to the naked eye on a clear night. To find Andromeda, first locate the constellation Cassiopeia. It looks like a giant W in the sky. Then look for the constellation Andromeda, which is just to the south of Cassiopeia. Andromeda looks like a faint, fuzzy star. If you have a pair of binoculars, you can get a better view. Binoculars will reveal Andromeda as a small, elongated smudge of light. With a telescope, you can even see some of Andromeda's individual stars. Section 8. The Cosmic Ballet. The dance of galaxies is a slow and majestic one. It takes place over billions of years, but it is a dance that is happening all around us. Our Milky Way is just one of billions of galaxies in the observable universe, and all of these galaxies are in constant motion, interacting with each other in a complex cosmic ballet. The collision of the Milky Way and Andromeda is just one example of this cosmic dance. It's a reminder that the universe is a dynamic and ever-changing place. Section 9. Endless Wonders. Andromeda is a reminder of the vastness and wonder of the universe. It's a reminder that we are part of something much larger than ourselves. As we continue to explore the cosmos, we can be sure that we will make even more amazing discoveries. Who knows what other secrets Andromeda and the universe hold? So the next time you look up at the night sky, take a moment to appreciate the beauty of Andromeda. It's a glimpse into another galaxy. It's a window into the past and future of our own, and it's a reminder of the endless wonders of the universe.